Okay, this is Mr. Nix, obviously, and I'm talking to you after not seeing you for a little over a week. Hope your Thanksgiving was good. Looking forward to Christmas as well. As you know, I'm out, and this is the COVID voice talking to you. Bit of irony here, considering that the last time I made a screencast, we were all on lockdown when COVID first hit in the spring of 2020, and it finally caught up to me, as it probably will to just about everybody. Feeling a little better, thanks for asking. And I'm going to be out for another few days at least, and it's time for me to get in touch with you. What I'm going to be doing here now for the next 50 minutes or so is lecturing through the work that you've already done. Actually, this is going to come in two parts. Part one involves the reading characteristics of man as an animal, for which you did the work, and for which this screencast is dedicated. So I'm going to take you slide by slide through this, and the idea here is for you to take the work you've done, which was defining the terms and working through the reading and trying to figure out what Clifford Geertz was talking about when it came to man and culture, and to marry it to this lecture, which obviously would have been given to you live had I been in school. So this is all going to lead to an examination, all right? So it's in your best interest, if you don't mind, to go through this, go through your notes, go through the work, and to get this down, because I'm going to be providing extra information beyond what you wrote and also clarifying what you already wrote as per the assignment. So let's get started. And it begins here with seemingly something outside the box here, a famous sketch that you've seen by Leonardo da Vinci from 1487, a Renaissance work of art called Vitruvian Man. It's based upon um, uh, da Vinci's interest in a Roman author and architect by the name of Vitruvius Pollio, which goes back to Roman times, the first century BC, who was known for his architecture and put kind of architecture on the map insofar as Western history is concerned, or at least helped put architecture on the map. And once again, you've seen this, and some of you probably know more about it than even I do at this point, but I included this because I wanted to do it as an intro to the reading characteristics of man as an animal. And the reason why I did this is because we're talking about humans. And we're talking about human evolution, and we're talking about man as occupying a special place in the overall evolutionary aspect of things. And here we have a wonderful depiction of the human form in all its proportions, in conjunction with greater laws that tie into geometry and even to the universe. So there's something special about humans, and that's what this is all dedicated to. So I thought I'd kind of show you something you've seen before and something that some of you have learned before if you're taking EuroCiv, or maybe you came across it somewhere else. But the idea here is that humans have evolved to occupy a special place in the overall scheme of things, and I thought this was a good image to start with because it doesn't really begin here, does it? It begins with human evolution, which goes back over 7 million years. And I know this is not standard history, I get that. And but I want to kind of go through this because it's very interesting to me, and I love the concept of human evolution and everything that ties into it: anthropology, culture, psychology, sociology, art, religion, and the human form itself. So we're not going to really get into the business of your notes until about slide 7. This is all prelude as a way of trying to kind of bring you into the concept and for me to justify what it is that I'm doing here in this unit, which is of my own creation. All right. Slide 2, here it is. Human history, right? That's what we're studying. That's what we're here for. World history, U.S. history, European Civ. These are all history classes. The thing about history, however, it only goes back about 7,000 years. Okay, well, that date already up there is a little long, a little wrong actually, because writing is invented somewhere around 4000 BC or BCE. So we're talking about roughly 7,000 years of human history if you want to bring us right up to date. I'm going to have to fix that slide. I'm not sure what I was thinking about, but you get the idea here. In the overall scope of things, history, technically, which begins with the invention of writing, as I mentioned before, is not that long. Yeah, so we're really studying a very small bit, the tip of the iceberg, as it were, in terms of the overall human contribution and human development over the course of 7 million years. All right, so here's a couple images to check out here, a couple concepts here. One, of course, is the idea that the brain is going to feature pretty prominently here in human evolution, and it explains why humans have what we call history to begin with. All right, and so this is part one: human evolution and the development of culture before history, characteristics of man as an animal. I love these images. Check them out. I think it's pretty cool, that bottom one there. Somehow maybe we've changed, and somehow maybe we haven't. All right, so we move on again. And here's just a more formal depiction of the overall concept in terms of what this unit is all about: characteristics of man as an animal. And that's what this lecture is dedicated to. What are the adaptive complexes, evolutionary speaking, biologically speaking, that have allowed humans to be so unique and to come up with this thing we call history? Okay? So without human evolution, there is no history. And here you have a characterization, or I should say a categorization of humans, which was evident in the packet. You probably didn't write this down because I'm not sure I asked about this. But in terms of us, okay, we are what is known as hominins. Okay, I'll talk about that in a minute. And as you go backward through the evolutionary experience, we are also related to primates because we are mammals and overall animals. So as we go through these adaptive complexes, slides 7 through I think 14, 15, something like that, all these adaptive complexes, in one way or another, we share with other animals because we are animals at the core. So as humans, we are both animal, mammal, primate, and something called hominin. Now this is where it gets a little confusing. Sorry about this, but I have to work this stuff out because assuming that you're going to come in contact with this stuff eventually in college or wherever, there's all kinds of terms out there, and some of them overlap, and they get a little confusing. And one of the confusing concepts here is, are we hominin or are we hominid? And the answer is we're both. We are hominids because we are related to the great apes. All right, and I'll show you a slide about that in a minute. In fact, we share more than 98% of our DNA with the great apes. So when you go to the zoo or you watch one of your nature programs or you go on a safari, or not really a safari actually, but somewhere in the rainforests and you see a gorilla or you see a chimp in a zoo or something like that, you might say, wow, they are really, really human-like. And of course they are because we share so much DNA. But even to say that they're human-like is a way of saying that there's something that separates us, and that less than 2% DNA, which comes over the course of evolutionary time, is what separates us from our primate cousins. But bottom line here is the great apes, us, our chimp cousins, we're all hominids. However, as humans, we are hominin. So there's a big separation there. Hopefully this next slide will help you out. So this is the family of the primate order, because remember, humans are primates, right? I went through that a minute ago. And as you can see here, the fossil record is always being updated. That's one of the kind of interesting but also problematic things about this unit, is seemingly every year they find another fossil which pushes human origins back and ties us into other beings in the fossil record. And so it's always being updated, okay, which is kind of cool actually, but it also makes these lectures of mine a little outdated almost as soon as they're given to you. In any event, we still know some very basic things, and what we know is that somewhere over 7 million years ago, humans and apes split off from a common ancestor, and this is what makes us hominids, right? We're all connected to a common ancestor, and so this slide very clearly shows where humans and the great apes diverged sometime over 7 million years ago, which is another way of saying, by the way, if you look at this little guy up here, this little head here. I'm not even going to try to pronounce this right now because it goes just too far back. These are the earliest human remains that we recognize as hominin, as humans, as related to us as human beings. And so we have two trajectories here. We have the evolution of the great apes, okay, and then we have the evolution of humans, culminating in us today, known as Homo sapiens, which goes back roughly 200,000 to 300,000 years ago. One of the cool things to take away from all of this, and by the way, in lecture 2, screencast 2, I'm going to go over this stuff here with regard to Australopithecus and Homo erectus and Homo neanderthalensis and Homo sapiens, which you already read about. And the bottom line here is that in terms of all human species that ever existed, going back at least 7 million years ago, we are the last surviving species, us, Homo sapiens. Okay, keep that in mind. We're the last ones. All right, all others have gone extinct over time. Okay, and the origins of us, Homo sapiens, well, once again, the dates are kind of out there. You'll see anywhere between 200,000 and 300,000 years ago in terms of all Homo sapiens that we're related to over time, and that is what this shows. Okay, I like this this chart here, this graph. I just threw it up here a few minutes ago. I just kind of found it online just to kind of augment what I was talking about. And what we have here in terms of human evolution are modern Homo sapiens, roughly 300,000 years ago, okay, from which we have descended. And all the things that we celebrate and we are capable of and that we identify with being humans are evident going back at least 300,000 years, which is pretty damn cool, okay? Nonetheless, humans themselves, hominids, and I'll go back to the previous slide, go back over 7 million years ago, all right? So modern humans, us, 300,000 years ago, all humans, maybe 7 million years ago, okay? Once again, this is all kind of prelude stuff. For you to kind of get a sense of human evolution in general. I'm sure this is the kind of stuff that you just have not come across before unless you do some stuff on your own or you took an anthropology class somewhere. I'm not sure where that would have been. But this is the kind of stuff, once again, you might get in college should you be interested. Okay? We'll move on. All right. Well, humans, and I'm going to kind of hammer this home time and again, are a migratory species. All right? And that explains a lot in terms of the reading you read, the characteristics of man as an animal, which I'll start to get into very soon. No other animal or no other species of animal, and no other species of human even, has been so successful as humans, as hominins, and of course, ultimately as us, Homo sapiens. We are a migratory species, and that's very key to keep in mind, okay? Starts in Africa, which I'll get into more specifically in the second screencast. But as you might know, or anybody who's traveled or watched TV, for crying out loud, humans occupy just about virtually all regions of the Earth. We're highly, highly successful. And of course, that's brought its own problems, hasn't it? Okay, we're ruining the planet, we're ruining the climate. Ironically, we've evolved to be so successful. We've also evolved, in a sense, to destroy ourselves. And if it wasn't through nuclear weapons at some point, although that could still happen, then it's going to be through climate change. So we're going to have to evolve again. I don't mean physically, but I mean in terms of our own planet and how we're going to live on this planet and make it. Because Homo sapiens, once again, have only been around for about 300,000 years, which is a drop in the bucket in terms of overall evolution of life, of course, going back maybe 6 billion years, but even a drop in the bucket in terms of overall human evolution. So, yeah, we're successful and we're highly prized, but we might be short-lived. I hope that's not the case, but who knows, okay? And it might be up to you guys to help to solve that problem. Here I go again, right? Why are we so successful? Why have we been able to migrate and to exploit all regions of the Earth? And the reason why that is because we have adapted and we have evolved these adaptive complexes, which you read about in the reading Characteristics of Man as an Animal. And there's the definition at the bottom of the screen for adaptive complexes. These are traits that have allowed us to adapt to new environments. By the way, there are not 11 of them. There are actually, 13 of them. This is a slide that was for my other class, the CP level, and I kind of cut it down a little bit to make it a little bit more streamlined. But I'm going to go over some of these, all of these, by the way, adaptive complexes. So strike that 11, and we'll start with number 1. And this is kind of where you guys need to really kick in here because you're going to have to now match up your understanding of these adaptive complexes to my lecture. Slides 1 through 6 was all preliminary. It was all just about kind of the human evolution in general, getting some terms out of the way, and also justifying this topic, okay, which you're not going to find in your standard textbook. But it's one that I really cherish and love talking about. So here you go. We're along for the ride. Okay. Adaptive complex number 1, homeothermy. Now, this goes back 150 million years ago. In other words, humans aren't the only warm-blooded animals on Earth, right? This goes back 150 million years, this concept, this adaptive complex. And once again, it goes back to the earlier slide where we share a lot of these adaptive complexes with other animals. But nonetheless, you add up all these adaptive complexes together with a couple of added things in there for the mix, which I'll get into, and it explains why humans are so successful. Homeothermy is the ability to maintain a constant core body temperature. I think we're all kind of aware of that, right? Because I've been taking my temperature every day, all right? And the ideal temperature, or the one that we kind of focus on in terms of humans, is 98.6, right? And when you guys were coming to school last year, you had your temperature taken every day, and it was all about, do you have a fever? What's going on here? What's your temperature? And it's one of the cases where what is an advantage appears at first to be a disadvantage, right? Because if you think about it, humans have a very narrow band in terms of our core temperature, right? If you start getting above 98.6, if you start getting above 100 degrees Fahrenheit, well, now you're in the danger zone. You're in trouble. You got a fever. You're sick. And if you go up too high, well, you're going to burn out, not literally, but you're going to die, right? You can't afford to walk around with 102, 103, 104 fever. That is just simply not healthy. And of course, that is life threatening. Similarly, if you start dipping down into low 90s and into the upper 80s in terms of your core body temperature, well, now you're going to get hypothermia and you're going to die as well. And so think about it in terms of evolution, it doesn't seem to make sense at the surface of it that humans would have such a narrow band in terms of their core body temperature. But that's the thing, okay? As long as we can maintain that slim band, we are good to go. We are energized. We are ready to deal. We don't have to hibernate like cold-blooded animals. And once again, if you think about it, human evolution and human origins, which begins in East Africa, but of course then extends all across the world, how would it be possible for humans to migrate into different environments and different climates if we weren't able to maintain a constant core body temperature? It would not be possible. So the advantage here is clearly that humans have what we call or maintain what we call a constant and lively body temperature. Okay, we maintain a constant and lively activity according to our core body temperature. There is no season that we cannot be active. We are constantly active. We are constantly looking for food. We are constantly improving and progressing. And a species that is migratory and going into different environments, this is a very distinct advantage. When you see other animals that have to hibernate in the winter, well, progress is going to be stunted as a result because they are not now engaged in a constant and lively activity that humans are. And as we will see in, I think, the next slide, perhaps, or maybe the slide after that, I'm not quite sure, that constant body temperature needs an enormous amount of energy. So we're going to need food sources in order to maintain that body temperature. And of course, eventually humans, as they evolve and as they move and as they migrate, are going to invent the very things that are going to allow them to sustain themselves in those different environments. So homeothermy, the ability to maintain a constant core body temperature, is a distinct advantage for humans because it allows us to maintain a constant and lively activity, and it allows us to migrate into any climate and environment. There you go. Okay? And there you go, just to drive it home, humans are a migratory species. I want to just kind of keep reminding you of that because that's key to this whole progress. All right? Well, it is the next slide in terms of your terms, right? In terms of your adaptive complexes. Humans are known for their heterodont dentition. We're not the only ones, but we kind of bring it to a new level. And what that means is we have different kinds of teeth that are able to perform different tasks when it comes to food, biting and chewing and that sort of thing. And that allows us, by the way, to exploit different food sources. So once again, there's that map showing us as a migratory species, starting in East Africa and then going throughout the entire world, encountering different food sources, whether it be plants or nuts or berries, okay, and grains, and of course meat. And that makes us, in terms of adaptive complex number 3, omnivorous. Okay, we are omnivorous characters or beings known as omnivores. And what that means is we are not tied to one specific food source. We can eat plants, we can eat meat, we are omnivores. Okay, so we can exploit all different kinds of food sources out there. And as a migratory species, that is a very distinct advantage. And one of the advantages here is the fact that we have different kind of teeth that can perform different kinds of actions in conjunction with the different kinds of foods that we consume. So now you tie in the idea of humans with a core body temperature, okay, warm-blooded, maintaining a constant and lively activity, migrating into different environments, coming up in contact with different food sources, the ability to exploit those different food sources, owing to heterodont dentition, in conjunction with the fact that we are omnivorous, okay, we are omnivores. And I think some of you know these terms already. You've taken biology, you're familiar with it, or you've learned this stuff outside of this class. But the idea is how do you tie them all together? And how do you tie these adaptive complexes all together to point to the fact that humans are so successful? Okay, so that's two terms right there, right now. One is the homeothermy, and the other is the concept of heterodont dentition, and the other third is the fact that we are omnivorous. Okay, we can exploit different food sources. Okay, we move on. Okay, I'm going to go back to this previous slide here. There's a little bit of confusion. Actually, for you, this adaptive complex number 3 is actually adaptive complex number 8. I put them together on this one slide because I wanted to bring these two together because they kind of go together, even though they're not in the order in which you read them. So as you're looking at your sheet, supposedly, as you're looking at your notes, as you're looking at the stuff you've written, you've already got homeothermy down, adaptive complex number 1. You've already got heterodont dentition down, adaptive complex number 2. But adaptive complex number 8 is what we're talking about here. The reason why it's number 3 here is because this is, once again, some of it's geared towards my CP level, and I had to kind of rearrange things and kind of get rid of some things to make it a little bit more simple for them. So going forward, as you can see, the numbers are a little bit off, but we move on. Now, this is adaptive complex number 3 for you. Okay, number 8 was the previous number 3, if that makes any sense. And this has to do with reproductive economy, and I love this stuff because this all ties into psychology, which goes to a later slide. But the idea is, how are you going to reproduce? Animals have all different kinds of way of reproduction. Of course, humans aren't the only ones who are, placental animals in terms of nurturing a offspring internally. Okay, a lot of animals do that, as you know. I mean, your dog does that, your cat does that, horses do that. All right, the list is almost endless. But I'll talk about the differences in a second. But to kind of bring an extreme difference here, think about how like lizards and fish do it and so forth, where reproduction is essentially external, in the sense that for fish specifically, they produce many, 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 many eggs at once, which are done externally, fertilized externally, and then it's kind of like a catch as catch can in terms of how many eggs are actually fertilized. Whereas humans nurture an offspring internally over an extended period of time. Not the longest period of time of any animal, but still, we'll talk about that in a minute anyway. And the question is, why is this an advantage? And you guys could probably come up with this. You read about it for sure. But I want to point out a couple things here. Now, you might think originally, hey, let's say, I'm going to design an animal and it has to reproduce. And why not millions of eggs or thousands of eggs? Okay, I mean, why not? The numbers are on your side. But of course, it's about ratio. So fish, as they exude, if you will, or project these eggs outward, waiting to be fertilized externally, it's kind of a crapshoot. And from a ratio standpoint, most of the eggs will not survive. They will not be fertilized, okay? Whereas for humans and other animals, of course, the ratio level of success is much higher, okay? And over time, that's going to really benefit the human being. And so the idea of nurturing the infant or the offspring internally, mostly one at a time for humans, adds up over time in a numbers game. Okay, and of course that internally nurtured offspring is being protected, and the likelihood of success for that one internally nurtured offspring is much higher. Okay, so on a ratio scale, this is a more efficient way and a better way to do it. Okay, and we're going to talk more about that and when we get down the line in terms of some other things about humans that make this even more of an advantage and more special. Okay, so that's reproductive economy. That is, how are you reproducing? What's the ratio of success in terms of the egg and the ultimate culmination of the offspring? Okay, hopefully that makes some sense. All right. Seemingly out of line here in terms of the reading is the introduction of this thing called the cerebral cortex. Okay, and this is, anybody who takes psychology kind of understands this because you've studied this, and certainly you've studied this in biology too, and here you are studying it again. This allows me to marry, my interests in history and psychology and anthropology, all wrapped up in the development of the human brain. Okay, and in terms of the cerebral cortex, we're talking about a ratio of size to body size that is the best in humans. And of course, the cerebral cortex is sort of the creme de la creme of human brain evolution. And it's the part of the brain overall, generally speaking, that allows for conscious thought. It allows for the expression of emotion. It allows for reasoning and language and memory and rational thinking and planning and impulse control and all the things that we think of when we think of a higher order being such as humans in terms of intelligence. And the brain, of course, is a product of millions of years of evolution here. And it's the humans who have the biggest cerebral cortex in terms of brain to body size ratio, which makes us the smartest animals on Earth. And once again, what's the advantage? Well, what's the advantage to having a big brain? I think it's kind of obvious, we can plan, we can progress, we can use language, we can use rational thought, we can self reflect, we can build things, we can invent things. And of course, the human success story is predicated on the kind of progress we've made literally over millions of years. And once again, as a migratory species going into different environments, if we couldn't plan, if we couldn't organize, if we couldn't work together, if we couldn't use language, we would not have been as successful as we are. We would have been stuck in East Africa, perhaps, or even extinct for that matter, much like many of our human cousins have gone extinct over time, because it's Homo sapiens who have the biggest brains in terms of the human evolutionary story. So all these adaptive complexes are really adding up to the concept of humans adapting and progressing and evolving in terms of new environments that go along with a highly migratory species. And the brain is the driving force over time for this kind of adaptation. So in the end, after this lecture, and after looking over your notes, after looking over the reading, you could write a pretty damn good essay in terms of why these adaptive complexes have made humans so successful over time. Homeothermy, heterodont dentition, the concept of being omnivorous, okay? The concept of our reproductive economy and nurturing our young and allowing for the success, ratio speaking, for the species to survive. And of course, the cerebral cortex, which is the creme de la creme of brain development in all life. All right, so hopefully you're looking at these slides. You're kind of getting the picture here. You can see if you compare the cerebral cortex of a mouse to a monkey to a human, we got it going on. Some of you who've learned about this in psychology, whatever class that might be, get this. Okay, we're getting there. All right. Just more about the cerebral cortex. Now, the texts that you read introduce the concept of the neocortex, okay, new cortex, which really just speaks to just another layer of cortical tissue added to the overall cerebral cortex itself, which allows for that much more brain capacity and brain power, more neurons dedicated to the functions of the human brain, which involves all the things that you see here on this graph in terms of the various lobes and the abilities that we have that far surpass other animals. Now, that's not that other animals don't have very specific skills that surpass human skills, but really, if you add it all up together, the human brain is a wonder of evolutionary adaptation. Okay? All right, adaptive complex number 5, the absence of estrus. Back to the idea of reproduction. Okay, and this really just speaks to a very plain fact that humans do not have a defined mating season like just about every other animal does. Okay, and hopefully the advantage here is kind of obvious, and that is that we don't have to have a narrow window of time in which to mate. And if that narrow window, for whatever reasons, could be climate, could be something else environmental, is lost, well, then the breeding time is lost. And the species is now under great strain and is on the verge of extinction, perhaps. Humans can mate at any time. And, if you just were to look up in the class as you listen to this and look at your fellow students around the classroom and think about the various birthdays that these fellow students, including yourself, have. And I bet you if you went around the room, all 12 months of the calendar would be represented in terms of student birthdays. Just kind of speaks to the fact that people are reproducing any time of the year. We are not constrained by having to hibernate. We're not constrained by a time when sexual mania kicks in and we have to reproduce because that's the narrow band of time that we have. Humans can, once again, don't operate according to the reproductive laws of estrus. Okay, we don't have estrus. We don't have a mating period. We mate any time, and the advantage there, of course, is we mate any time, and we're not beholden to the environment or to a sexual mania in the interest of mating. And the other side effect of that, or the other advantage of that, is we don't have to drop everything to go off and mate. Okay, we can mate and get on with our business. Okay, you can spend your day at work, okay, your day at school, or whatever the case may be, and go home and engage in the mating ritual in the interest of having offspring. Okay, so hopefully absence of estrus is pretty obvious to you in terms of advantage for the human species. All right, this is pretty cool, and this is speaks to really what we call a positive biofeedback loop that involves the human brain as well, and it deals with the emancipated hand. Okay, everybody knows that human hands have an opposable thumb, but everybody also knows that many chimp species have hands that are very similar to ours, and they can grasp things, and other animals can grasp things, but really nobody can grasp things and manipulate objects to the extent that the humans can, because our hand with the opposable thumb is structured as such. And part of that has to do with, or much of it has to do actually, with the fact that we are what we call bipedal. Now, I don't have that in this particular lecture. That's actually for another time. But I'll go back here and you can clearly see that humans walk upright. That's what bipedal means. Two pedal feet. Okay, 2 feet. We're up on 2 feet. And once humans evolved to be bipedal, and we'll get into the reasons for that in the next screencast lecture, the hands were in a sense freed. Okay, freed to develop along different lines. They weren't necessarily anymore for perambulation. Okay, we're not quadrupeds. We don't have to walk on our forelimbs. Okay, so the hands, in a sense, became freed. Now, the concept of the emancipated hand really has to do with two things. On the one hand, when we went bipedal, the hands became freed. Okay, they became more sensitive, less coarse. They lost their padding. They lost their hair. The nails became shorter, and the hand once again more sensitive. And with the opposable thumb, the hand became something that you could use to grab and manipulate objects. Okay, not only climb trees, right, which we were doing, but also now to explore the world and to manipulate objects. And with that comes a positive biofeedback mechanism where the manipulation of an object and the ability to manipulate it is actually going to spur on brain growth. All right. That's not the only thing the brain's going to respond to in terms of this positive biofeedback mechanism I'm talking about. We'll get to that later. All right. So you can imagine an early human walking the savanna of East Africa as it's evolving to be increasingly bipedal, and the hands are becoming more sensitive, as I mentioned earlier. And now this bipedal early human is beginning to explore its environment, not only visually and through other sensations, but tactically, in terms of picking up objects and manipulating objects and looking at these objects and trying to figure out what these objects could be good for, and perhaps even what these objects could be made into, right? And that's going to spur brain growth. Okay, so let me tell you how this can work. So, if I were in class, this is what I would do. I would pause right now and I would ask for a volunteer, and someone would volunteer, of course. I'd actually ask for 2 volunteers because someone would have to be the recorder and someone would have to be the person I'm experimenting on, so to speak. And what I would do is I'd bring out a pillowcase, and in that pillowcase would be 5 random objects. It could be a pen, it could be a paper clip, it could be that glass paperweight thing I have in my desk. Any 5 objects would do. And I'd put it in the pillowcase, and I asked the student who's the volunteer to blindly put their hand into the pillowcase and to feel around and to identify the objects in the pillowcase. And lo and behold, almost every time the student pretty much gets 5 for 5 or 6 for 6, depending upon how many objects are in there. Even if they're not really sure what the object is, they'll describe it. And the recorder would write it down, and sure enough, I'd pull those objects out of the pillowcase, and lo and behold, once again, those objects would prove to be what the student described them as. How does this work? Well, what you have here is a student feeling objects without looking at them and describing what those objects are. So clearly there is a biofeedback between the hand, which is now manipulating objects, and the brain, which is imagining and envisioning and figuring out what those objects are. That's pretty cool if you think about it. No other animal, well, most other animals couldn't possibly do that. All right, much less, not manipulate the object, but much less figure out what that object is simply through the hand. So the emancipated hand was freed for these purposes. Okay, but the other concept here is the emancipated hand, according to the text, and along with this big brain we have, has emancipated us from evolution. All right, the idea being is we no longer need to evolve physically, genetically. Because of our emancipated hand and our big brain, we are able to do and build and make the things that evolve for us. Okay? So we don't need to develop wings to fly from point A to point B. We build an airplane and we get on it. We don't need to redevelop flippers and gills to get into the ocean to swim across the Atlantic to get to Europe, because we can just get on a boat and do that, or once again, get on a plane and do that. So, this is kind of out there a little bit and theoretical, really. But once again, two things before I move on. The hand itself, through time and through evolution, and because we're bipedal, was freed from an object of perambulation to now an object, if you will, or an organ, if you will, or an appendage, if you will, that allows us to manipulate objects and to now work with a growing brain to progress forward. So the emancipated hand, the hand itself has been freed, but then again, according to the text, the hand itself, along with the brain, has freed us, humans, from any further genetic change. Because if the environment throws something up that we might need to adapt to, we simply just build our way out of that. All right. Really quickly, the hand on the left there, that's a CAT scan, I believe it is, of an infant's hand, okay, that's developing in utero, a fetal hand, by the way, that's developing in utero. I don't think it's CAT scan. It's probably a very highly resolutioned sonar, okay? In any event, what that shows here, if you look at these fibers here, these are tendons that are actually present in the hands of lizards, right? Which is really cool. It kind of shows the connection in terms of evolution with us and other animals. Remember, humans are animals, right? That's kind of the core thing here. So we share a lot of properties with other animals. Now, these tendons here, they're not present when we're born because we're not lizards. So even though at one point during fetal gestation, we have the hands almost literally of lizards, because we're not lizards in terms of our genetic makeup, these die off, they go away. These cells basically become extinct, or I'm not really sure what the word is. For you guys who know biology, you might know that word. I thought it was a cool shot. Enough in the hand. Let's move on. All right, here's a couple things that I left out of the CP class that now I have with you guys. That's why the numbers were a little off. That's why I said 11, but it's not. It's more than that for you. Two things here: Cope's law of the survival of the unspecialized, and alloplastic evolution. Okay, Cope's law of the survival of the unspecialized. Pretty straightforward. And what that means is humans themselves are not designed, evolutionary speaking, specific to an environment or a climate or a region, much like many other animals are. We are unspecialized, okay? We don't have large teeth for the purpose of hunting big game like the saber-toothed tiger did, okay? But what happened to the saber-toothed tiger? A formidable beast, a great hunter, very successful, around for a long time, but no longer with us. And the reason why that is because it was designed very specifically for a particular environment that involved a particular game, particular prey, and it was very successful in hunting that prey. But once that prey was extinct, so too would the saber-toothed tiger become extinct. Because you can't eat berries and fruits and nuts or whatever with these kinds of teeth. That's just one example of the many, many, many animal species that have gone extinct over the years. Okay, this is a Darwinian struggle, right? Survival of the fittest, as they might say. Okay, those genes that are more adapted to an environment are the ones that are going to be passed on. Well, humans, because we're a migratory species, we have not adapted to any specific environment. We are unspecialized, all right? Once again, we build our way out of whatever environmental concerns we have. And so we are not suited to a particular environment, in terms of Earth, of course, that is. And so Cope's law of the survival of the unspecialized dictates that because humans are not specifically genetically evolved to an environment, we are successful in all environments. We are unspecialized. There's nothing about us that will make us go extinct because we've over adapted to a particular environment, because once again, we have to survive in all environments. I hope you get that. And alloplastic evolution is kind of related to that, and also kind of related to the emancipated hand. The concept here are two things, basically. One is autoplastic evolution, and then there's alloplastic evolution. Autoplastic evolution is evolution, Okay, it's what we call the blind genetic gamble. Darwinian genetics, Darwinian evolution. The idea being is those genes that evolve for a particular environment are the ones that are going to be passed on, and that species will be successful in that environment. That's autoplastic evolution. That is, we are given to the laws of genetic evolution, which of course humans have been for most of human existence. All right. However, the claim is, this is a claim, it's theoretical, we are no longer given to the blind genetic evolutionary gamble, if you will. We evolve alloplastically. We evolve outside of evolution. We evolve outside of genetics. Okay, because of our emancipated hand, because of our brain, because of our ability to adapt to any environment, owing to our technological progress, we are no longer subject to evolution. We evolve outside of evolution. We just simply build our way out of the problem. We evolve technically to solve the problem. And so that's who we are. And humans haven't changed in literally tens of thousands, hundreds of thousands of years. Okay, there's been absolutely no or virtually no clear down home genetic changes in terms of human evolution over hundreds of thousands of years, because we have been able to technically solve those problems. So I hope you get that. All right, we're getting there. Adaptive complex, number 8, not really for you, but whatever. Okay, and the concept is the fact that humans are not the only animal that breastfeeds, but it's the placement of the nipples high on the chest that is key here for humans. Okay, once again, we're not the only ones who did this. We're mammals. So all mammals breastfeed. That's what makes mammals mammals. Okay, they all have tits. But humans, it's a little bit different here in the sense that the placement is high up on the chest, and this has many advantages. One of which I'll tell you about, one which is pretty obvious, I think, given this scene right here. Okay, and I'll get into the concept of culture in a second. But what's the advantage here? Well, for a migratory species, being able to hold your infant high up on the chest is key, because now you can migrate and feed at the same time. You're not, basically kind of sitting down like cats and dogs are with a whole litter there. Okay, and once again, back to reproductive economy, we only nurture basically one at a time. This is very advantageous for a migratory species. We can carry our infants and still migrate and still be able to use the other arm for whatever tasks might be possible. Okay, so that's an advantage. The other thing here, and this gets into the realm of psychology and kind of now starts to bring this whole reading together, because culture is really the backdrop of a lot of this, is the fact that humans holding the infant high in the chest can begin to start communicate. Okay, anybody who's ever held an infant or fed an infant or watched someone feed an infant or just looking at this picture here kind of gets that, right? So what we have here is a woman and her infant not only feeding but communicating, eyes locked into one another. There's learning going on here. There's the passing of what we call the extra genetic transmission of information. Okay, because the ability for humans to learn is the key to our success. So placing the nipples high up on the chest here not only allows humans more ability in terms of to migrate and to move around and to not be stuck in one place, but also to start the process of communicating and process of learning. And that's what culture is. This is where Clifford Geertz starts to come in, because I asked you about that in the last question of the reading. Okay, what is Clifford Geertz saying about the connection between these adaptive complexes and human beings? And I'm going to give it to you right now. Okay, the definition of culture, the best I've ever heard, and this goes back many years, is it's a blueprint for living. Right? We all speak language, but English is part of a culture. Hebrew is part of a culture. Spanish is part of a culture. We all wear clothes, but the kinds of clothes we wear are culturally determined. Okay, we all have some kind of spiritual faith, perhaps, but it's the religion that we belong to that is the kind of culture that we speak of. Okay, and we're not born with that. That's the key here, right? And humans themselves are born, I don't want to say rather pathetic, but they are not, what's the word I'm looking for, precocious at all. They are born with very little instinct and very little skill, and that is exactly the point. All right. Other animals who are precocious are pretty much born ready to go. Okay, if they're not up and running or up and kind of fending for themselves in a short period of time, well, they're not going to make it. All right. But humans, of course, are born without almost any instinctual abilities. Certainly, no learning, no culture. All of that has to be taught outside of the womb. And that, what seems like to be a disadvantage, is actually a clear advantage because we spend many, many years learning what it means to be human. And that's the point. If you take all these adaptive complexes and you add them up together, what you have here is a very unspecialized species that doesn't know what environment it's going to be born into and therefore is not adapted to any particular environment, but yet has to learn everything it needs to know for that environment. And the process begins right outside the womb when the mother and the baby begin the breastfeeding, bonding, social emotional connection, and learning process. And that is the key here. And if you look at the definition of culture, you kind of get the point here. Okay, the extragenetic transmission of information. Once again, if humans were born adapted to a specific environment, what would seem to be an advantage? If humans were born precocious, ready to go, right off the gun there, in terms of that environment, well, we'd be a successful species in that environment. But the problem is, we're not beholden to any particular environment. I've said that time and time again. So we cannot be born with the instincts and the knowledge of that environment because we don't know what environment that environment's going to be. Everything has to be learned. And while humans don't have the longest gestation period in terms of in utero development, we do have the longest period of postnatal dependence. After all, you're 17 years old, you're 16 years old, you're still living at home, you're somewhat independent, you're someone on your own, of course, in terms of the decisions you make, but you're living under your parents' roof, okay? And they're taking care of you, and they're making sure that you get what you need as you go through high school and then college. You're going to spend the better part of 21 years in terms of this postnatal dependence. And that is going to allow you to be a very successful person going off into the world. So there's a lot going on here with this particular adaptive complex. Yes, it does come down to the placement of the teats on the human or the mammal, but it's also about reproductive economy, one human at a time, generally speaking, and a long period of postnatal dependence where this extragenetic transmission of information is crucial to the success of the human organism. All right. And that is what culture is. We are not born with culture. We learn culture. We become a part of culture. All right. Okay. Just about last but not least, symbolic behavior. All right. Now, I know you've been kind of listening to me and kind of waxing and waning on this. I get it. It's a long lecture. If we were in class, this would be a little bit better in the sense of, I could be a little bit more articulate in front of you. I could be a little more, in terms of my gesticulations, that I can kind of ask questions, that I can ask for volunteers, and there'd be more back and forth. It'd be a little bit more interesting for sure. But this is the best we can do under the circumstances, so just kind of ride with me. The point being is over the course of this whole time I've been talking to you, I've been communicating with you symbolically. I've been using language to connote very complex and sophisticated ideas. And human symbolic behavior is really one of the big keys to being human. Because after all, if we could not communicate symbolically, we would not have been successful. We could not have organized our earliest migration patterns. We could not have organized our earliest hunts. We could not have invented fire itself, enabling for the increase in symbolic behavior, some of which I'll get into the next screencast. But it's the symbolic behavior that humans are capable of that really raises us above all other animals. And of course, this has to do with the construct of the brain, which has evolved specifically for language. Okay? And so here are just some very basic examples of symbolic behavior. On the left there, those are shells. They came from the ocean. They were found on the west coast of Spain. They date some 40,000 years ago. But you can see that there's something more to it here. Humans have done something to this. Okay, there's a purpose. And what these shells are basically are necklaces. Okay, the rope itself has biodegraded, but the shells have remained. And so going back 40,000 years at least, okay, it probably goes further back than that, humans are engaged in the symbolic behavior of making jewelry. because jewelry means something. It's worth something. It identifies something. It says something. So you go back 40,000 years, you walk along the coast, west coast of Spain, you're going to find a human who looks remarkably like you, okay, who is basically you, and they're going to be wearing these shells, and you can be, well, that looks nice. What'd you do with that? How'd you make that? Well, why are you wearing that? Is that status? Okay, are you just adorning yourself? You're making yourself look good? You're trying to attract a mate? What's going on here? So just the fact that we wear clothes and make jewelry, okay, it goes way back. And that's symbolic behavior because it says something more than just a shell on a piece of rope around your neck. And of course, the ultimate example of symbolic behavior is language, okay? And culture is what that language is, but all humans have the ability to use language. And what we have here are symbols. Okay, these are just symbols. They don't mean anything in and of themselves. They're just lines put together in such a way that we've attached meaning to them. Okay, and this is just an example in Hebrew because it's Hanukkah. I threw Hebrew in there, but any language would do. Just look at the alphabet, right? 26 letters, but they're just random shapes. But we have attached meaning to them. We've attached sound to them. We've put them together to form words. We've put words together to form sentences and to connote meaning. And that has, obviously enhanced our ability to communicate. Without language, we're pantomiming at best. And even in this long lecture to you for sure, but still relatively short period of time, communicated a whole host of ideas to you by using language. And of course, you've read about this stuff already by using language. On the right there, just another symbol. Okay, what is that? Well, you probably think it's a cross. Right, what does that mean? It's a religion, Christianity. Okay, well, now you can spend the rest of your life talking about Christianity if that's what you want to do. And any other religion that might be related to Christianity or not Christianity. But we're into the realm of religion all of a sudden by looking at two perpendicular lines. Oh, two perpendicular lines. Maybe we can talk about algebra, math, and we could spend the rest of our lives talking about that. All we've done is put two perpendicular lines together, and now we have at least 2 lifetimes worth of activity and knowledge and concepts to talk about. Symbolic behavior, the brain, a huge adaptive complex in terms of the ability of humans to progress. And that's where we leave it. This is the beginning of the next slide for the next lecture, which will be coming at you soon. All right. I'm going to finish really quickly here by saying I hope you got a lot out of this, or at least something out of this. I really felt like I had to kind of go through this because I wanted you to hear me. I wanted to communicate with you, touch base a little bit because I haven't seen you guys in a while. And I also wanted you to marry the notes and the reading to the concepts and the lecture. All right? I'll be back in touch soon. Hope you guys are doing well. Take care.